that you decided to join this session. My name is, funny name, Jakub Marchwicki. I came over here from Poland. And this is my first talk in Holland, which makes me a little bit nervous because whenever I do it speaking, like in Poland or in Czech Republic or anywhere in my area, I pretty much know, I know the people, I know who I'm talking with, I know the companies, I know what they are doing. Now it's a complete mystery, and it might appear that what I'll be talking about is just obvious to you, and I'll be just standing up silly here, or the other way around. I don't know, and that's a challenge for me, which I'm quite enjoying. The title of the talk is What is Code? It's a fairly new talk. It's the third time I'm giving it. I've spoken it in Poland, in Czech, and now in Holland, and each and every reaction was different. So that's additionally challenging. Okay. One of my first feedback after the talk was that this shouldn't be called What is Code. It should have been called What is Project? Because I will cover multiple things that our projects are composed of, and they are not and we are not treating them as code, which is a source of many problems, at least in my opinion. Yes, this is a little bit opinionated talk. So what I'll be covering is I'll be covering a little bit what we actually do in projects, besides just coding. And is code everything we do in project? Are there some other activities beyond that? Like, what about the business? What about the operations? What about testers? And this is not a soft skills talk. I have lots of code snippets on the slides, and I have actual code. And I think it depends on you what you prefer to see. Like, I can, within the presentation, I will be walking through some code snippets. I can skip them and go straight to the code and show how it's actually working in a real compiling project. So who is in favor of code? Okay, and who is rather slide snippets? Okay, sorry, you're voted out. So I'll skip some parts of the presentation, and like 10 minutes before, I'll jump to the well, to Sublime and show you how it might work in code and how it's actually working, how it actually can be done. And also all the code is available on GitHub in case you would like to fiddle on your own and so on. So a few words about me, which is not very much of interesting. I'm coming from Poland and I work for an educational company and do lots of other stuff. So the first thing to ask is what we are actually doing. Yes. Whenever you get into a project, and that's a situation I find quite natural. Most of people who have a developer background rush to IDE and to cut some code because code is something we love. One of my former university teachers used to say that developers are paid for writing documentation because writing code is a pleasure. It's hard to disagree. So, but reality is that before we start coding, we usually get a bunch of documentation and then even more documentation with the changes, and sometimes changes are documented itself, so we have even more documentation. And then we do some coding, and then usually we should shift it over to some other department called operations, like throw it over the wall, or sometimes we don't if you're a DevOps, depending on the reality. We are faced with some tedious data migrations and so on and so forth. Lots of things, and then we have testers. If we are lucky, we have testers who do automation. Otherwise, it's iUnit, so iLook and unit tested. There's lots of stuff going on in the project that has no relation to actual code, and we, as developers, have a certain notion how we are treating the code. And I think it's git flow, all the things. And the question is, can we run project, can we run all the artifacts within the project as if it was a source code, and we can git flow it, and we can work in the same way we work with our source code doing a transparent code review through pull requests, and have everything within the source code with all the transparency related to it. So all the changes, all the blames, we know who changed what, and so on and so forth. That's a thesis. So let's see whether it's possible. So let's talk about documentation. When it comes to documentation, at least from my practice, we have different toolings. We have Excel spreadsheets. My business people love Excel spreadsheets. Usually the business requirements start within the Excel spreadsheets. I don't know why. Probably because it has tables out of the box. Maybe. Then we have tooling like Enterprise Architect, another silo, another big tool that we can put everything inside. No matter how it begins, it usually ends up in Confluence. Okay. And then, if we are lucky and smart, we get some additional documentation generated HTMLs from our source code. I will tackle that upon. So, if we look and if we try to draw it, and I found a diagram from SoundCloud guys, we see that our documentation within a project is widespread through multiple silos. If we are hip, it is like Google Drive and Trello and Pivotal Tracker. If we are more enterprise-ish, it is usually SharePoint and Confluence and some other tooling. There are silos that we put our documentation inside, and there is no way to get it back easily to put it in the other silo. Okay, it usually happens because people are writing some parts of the design or of the requirements, the design, whatever. People in charge of doing this stuff, which is time-wise before coding activities, usually put it into things that are in their comfort zone and they like it and they don't really care, what will happen with that next. I'll just generate PDF for you. So that made me think, okay, so who are the docs for? Who are the documentation for? And then I thought, okay, we have multiple stakeholders, let's say. We have project managers, product managers, developers, analysts, user experience designer, operations guys, and so on and so forth. And usually within a project, developers is the biggest group. That's the biggest group of people, and they are very much dependent on what actually has been written. And they are their biggest concern is how the documentation is evolving. But on the other hand, we are still writing it down in a way that it's not very approachable by the standard developer's workflow. So what is wrong with that? I think I have another picture to illustrate it. That's from one of my recent documentation, requirements or architecture, functional description document. Pointing out two important things. This is a version 0.1. It has 155 pages. And after 2 or more weeks, this is a Polish word. That's another thing. After 2 weeks, I have release 0.3 with very slight changes, as you can see in the description, 70 pages less. Say what? There's no way, if I deliver functional descriptions, for example, that way, I can track changes. I can actually see what is missing or what has been added. And, as a developer, I just diff to files and I see who was adding that. Yeah, I can diff to files in Word, but whoever has done it knows it's far from being perfect. I just need the meat. I just need the actual changes. And then, okay, that's a documentation, but then there's the whole flow, how it works. And for example, with one of my projects, it worked pretty much like this. So we had an Excel spreadsheet and an Enterprise Architect. Then there was a document generated from the Enterprise Architect to get into the Confluence. And the Jira tickets were linking to the Confluence, as well as some else things were, just mess around. We just spread the documentation around multiple silos, and we treat it as architecture documents and design documents and functional descriptions. And yeah, that was really wrong. So what I thought is what we are actually putting inside those documents and whether this should be within those documents. and whether we are putting too much in there or too little, or why the documentation is becoming outdated so quickly. Maybe we are just doing it wrong. So I thought maybe there should be a distinction between, let's say, architecture and the design. And we can treat architecture as something that is not changing through the project. You know, if the architecture changes, then we are actually doing a different project. And there is a design which is a very, which changes much quicker, and usually it is like we have a rough idea how we're going to design things, then we get into implementation, and the implementation just goes in the different directions because there are lots of things we haven't thought about up front. And then we have, you know, we have design documents saying one thing, and then we have implementations telling the other, and there is no way for us to look back, you know, and see how, you know, those things change. So can we put design as code, like ditch all the documents and have the design of our solution as code, so that the code will be the only truth, and whenever we change something in code, we will be, you know, we'll know it out of the box through changes of some documentation. I think that what we are trying to avoid pretty much with that is something like this. When the flow between two layers is looking like this in real life, but what we had on the documentation was pretty much like this. Now, the thing is about, you know, architecture versus reality. And this is something we are not very good at. So, design as code. I've taken an example of a very simple design pattern. Entity control boundary. It's so universal that you probably can derive every architecture and every other design pattern through it. And looked how we can visualize from code each and every part of the system. So we have entities, our data models. No matter whether we have, you know, enterprise data model or canonical data model, or we are having just microservices with the smaller models underneath. We can easily generate some design documents directly out of it. There's a tooling that has been there ever since. I will not tackle that point. But there are two other things that are important. The boundaries, our endpoints definition. So the interfaces our application is communicating with the external world, and the control, how we describe the flow, the processes that are within the applications. And I have the two toolings around that, which I'll mention, and then I'll show in code. I'll start with the boundaries. Who is using Swagger in here? Okay, quite a few. That's good. So Swagger is a language-agnostic interface to describe REST APIs. And the idea is that if we build something within a code that is actually sending some requests and able to consume some other requests, this is the ultimate truth. This is how our applications behave, and we usually do not care how it was designed. What's really important, how it's actually working. And Swagger is a tool that can either top-down, we can think how it should work and then generate the actual implementation out of this design, or bottom-up, which I personally prefer, that we build the documentation out of the existing APIs. It looks like this. You get your, this is actually this is JAX-RS snippet. So you have your JAX-RS annotations and some other annotations which just describe in a human language what this application is about, and there is an actual implementation that gives the response. And based on that, or some more YAML-based description, the Swagger can generate us an HTML page which describes the whole flow of the application. I will show it in a second. Obviously, you can get a PDF out of it and so on and so forth. I'll just skip it to show you the actual code. The other thing, so that one covers the boundaries, the interfaces. Now we have to describe also what the application actually do. So write at least few sentences or few activity diagrams or sequence diagrams what the app is about or what this module is about, what it's actually doing. And I personally like ASCII-Doc and try to use that for it. Who knows ASCII-Doc? ASCII-Doctor? Okay, who knows Markdown? Okay, ASCII-Doc is pretty much like Markdown, but better. So ASCII-Doc is a syntax, like Markdown, but more complete. Have you ever tried to describe width of an image within a Markdown? It's not possible without HTML, and ASCII-Doctor, that's a part of the syntax. So it's more complete, and there is an ASCII-Doctor with a set of tooling that allows you to edit, read, version, share, convert, do whatsoever with the actual documents. And the documents are just the text files. This is a simple file. Even though you might be not familiar with ASCII-Doc syntax, it seems reasonable what's in there. There is, I think, some heading and some source code and some annotations. It's pretty much human readable. When I render it, it looks pretty much like this, so I get a document. So what I can do now, don't have any more design documents, I can put everything through code. Let's look operations. Documentation is the upfront, the operations is usually what happens later. I assume we are not working all DevOps because it's not that widespread, and it takes time, a lot of time to crunch this wall. So operations is on one hand deployments, but also the provisioning, the changes of infrastructure, the migration of data on production, and kind of monitoring all of this. If I go to the scope, I have infrastructure, I have application deployment. That's actually what our operations are doing. Have data migrations and monitoring. And when it comes to operations, I think there's one important factor that counts when it comes to operations. It's called people per server ratio. When I talk about average in the industry, average technician or average operation engineer is taking care of about 250 up to 500 machines, like servers whatsoever. In the place I work, we are still not there yet. We have, on average, depending how you're counting, from 100 to 500 machines. The thing is, the guys at Facebook have 25,000 per one technician. Challenge that. And if we would like to get there, we definitely need to change the way we behave with shifting, the actual code from one silo to another. How it worked for quite a while in one of my projects is that there was one interface with the operations. It was SVN. So whenever we were done, we were committing it to SVN, and they were doing SVN up. And that was all the communication we had, which definitely was an anti-pattern. If we would like to change that, we would like to set up some principles. Say, I would like to use Jenkins for everything because, well, not Jenkins per se, but a continuous integration tooling. I would like to never look back, so have a deployment that will just roll forward only. And I don't want to log into servers. That's kind of my principles. And then if we have those, we can look for some tools for the job. There's lots of things that is covering so-called infrastructure as code and allows us to prepare the machines through some code, through some scripts, not necessarily bash scripts, something less verbose, something more domain-specific. And then we can just roll it forward. And if it doesn't work, we just change it and roll forward only again, again, and again, and again. There's a lot of tool around it. I will show a little bit of Docker, who is using Docker, like as a sandbox at the beginning, like on your local machine. Quite a few. Who is brave enough to have it on production? Standard question. Docker is a container thing. Vagrant is virtual machine thing. Then we can script it through Puppet, Chef, Ansible, Terraform, whatsoever. There are multiple things. So with containers, the whole idea is to be able to encapsulate my application within something that I can run on production, so that we have this dev to ops parity, that whatever on production it's on my developer environment. And we don't have a situation that, well, it worked for me. Yes, it worked for you because we had a different environment. So if we can get to this notion of dev and ops parity, there are tools we can there are tools that allows us to use exactly the same toolset, exactly the same environment on both cases. I remember I had a situation in one of the projects where because we didn't have the same environment for testing, we get into a very brutal bug that wiped out all the file system on the production machine. Because when we were opening a file, we've set up a wrong flag, and then and on production machines, there were two machines talking through network file system, and we had a wrong flag. It just didn't close the file, and it wiped it out. We've noticed it after a few weeks, I think, and that was the thing because it worked on our environment. So that's something we would like to rather avoid. You can get to Docker file through Maven, for example. I'll skip it and show it later on. You can do it same without containers. So you don't have this container abstraction. You need a virtual machine. There's a tool called Packer that can provision you a virtual machine of your choice, whether it's an Amazon image or whether it's Xen image, or whether it's a Vagrant file, whether it's a VirtualBox image, whatever you would like. It can provision you, so you have a baseline, and then you can use your favorite provisioning tool on the top of it. That's pretty much how I would like to work with the operations. I will show it in a second in the code. There's one more thing missing in operation scope. There's a data migrations. This is something I think we are all in, that we would like to migrate from one environment or from one release to another. It includes some database changes or some data changes. So there is a tool which I personally like FLYWAY. Who's using FLYWAY or Liquidbase? Okay, quite a few people. FLYWAY is a tool that handles the job for you, which script actually has been run in this environment, and whether you have to run the script again, or whether you have to run some scripts to migrate the data, or you just don't. What I like about FLYWAY is FLYWAY does not bring any abstraction on my SQL database. Like SQL is the first-class citizen there, and I just write my scripts in SQL that are run against my database. So that's very simple. I don't like all those XML abstractions because usually they are just leaky abstraction and you don't change your database model, your database engine that often. So how it's work, you put somewhere in your source code the actual SQL files that are incremental changes to the database, and then you can either run it with the command line utility like FLYWAY migrate. That's not fun. You could put it into your application. This is a Spring example. So I'll stand here because there's before you get your entity manager or your just data source initiated, it depends on FLYWAY, which migrates the data at the data source. How it does it? It has tables called schema version, and it holds all the information that has been done on the database within such form that, yes, I've installed it, this is this version, a small description, SQL, and then what has been migrated. So that gives me an opportunity as a developer to actually see what has been run at one environment and on the other. So this is operations. There's also this monitoring thing, which I'm not tackling. I haven't found yet idea to how to do the proper monitoring as code altogether. But especially in more distributed environments, that's something still to understand. But I think that just shifting from the manual operations to automated operations just gives us, let's call it operational sanity a bit. But if we are talking about shifting from manual work to automated work, let's talk about testers. That's the third part, and the last part before I jump into the code. So testers. What does QA stands for? There are many definitions depending on the organization you're working. This usually quality assurance, so testers, I call them checkers, no pun intended. Sometimes there are quality analysts, so there are people who are, to a certain extent, doing the analysis, trying to help the developers understand what's exactly needed to be built. But what I really like is the notion of quality ambassadors, so people who are just bringing awareness of the quality within the application and trying to enforce the actual checks on the developers. That the idea for the engineers, for the developers, is that they are aware of the consequences of the changes they are bringing, and they are actually testing that, not the testers. If the testers are doing that, I call it TDD, tester-driven development. That's not a good term. And if we get to shift the responsibility for quality also on the developers, the natural thing is for the developers to do everything as code. And then we get to two things that are quite interesting in the area. We have this so-called cucumber BDD style of thing. So we try to define behaviors, like features or fixtures. We use it with a tool called, usually, Cucumber. That's the oldest one. And we run tests based on that. Who's using Cucumber in their project? Are you fond of it? You like it? Yeah, exactly. The thing is, we have this idea as the developers that we will onboard business, and business will write us those features, those stories, that, for example, we have the translation application, so given I have a word, blah, I want to translate it, and then I guess get a size of translations which is like 24, and the first word translated is like this. And then JBehavior or JCucumber generates a part of implementation, of a test implementation, where I have to fill all the gaps, usually based on the regular expressions. My practice is that, then I run it, and then I have a nice-looking HTML table that actually shows to the business guys what has been testing, what scenarios has been evaluated, and so on. The problem I see with that, well, I see two problems with that. First problem is that a business hardly ever writes those stories. We would like them to write that, but they have different notion of that. So they are not writing the stories. So the stories are written either by testers or by the developers, and none of those are happy with writing just the stories. If they are developers, they would like to write an actual test. And if they are testers, they feel like not a test monkey, but a stories monkey, which is not also happy with, they are not happy with. So I think there is, and whenever it comes that the testers are responsible for building up the stories, at least from my practice and from the testers I'm working with, the testers are really keen on learning how to code, in general. There are two types, in my opinion, there are two types of testers. Those who are not fond of coding and though are going to the path of more or less analyst, and those who are very keen on coding. They learn SQL, then they learn some scripting languages, Python, for example, and start doing operations and stuff. They are fond of coding. So I'll talk about latter. So if we have a bunch of testers who would like to learn how to code, I have an alternative to Cucumber. It's called Spock. Who has heard of Spock testing framework? Okay, quite a few people. So Spock is more or less testing specification framework. It's written in Groovy, but it works with Java quite good. And it's very expressive, and it's quite beautiful in what you write. This is an example of a Spock test case. Test scenario. It's a domain-specific language based on Groovy. And this looks pretty much acceptable for most of the testers I've been working with. You have sections when, then, and, where, or expect. There are multiple keywords around it. And given that they know where to put what kind of code, there's not much stuff going on. So we have, this is rest assured using here. So given that we have to call this code, we are looking for a response called HTTP 200, and then we have some response which we are treating as string, getting English words, see the responses, and so on and so forth, and the familiar table from Cucumber. Most of the testers I've been working with, it's not that we've come on with an idea, you will be writing that. It was other way around. The testers were using SOAP UI for that, and they started learning Groovy to script the SOAP UI effectively, and they came to us and how can we learn Groovy to make better, you know, within this SOAP UI small console to type in those scripts. So we said, well, maybe you just try it, try that one. And well, they're quite okay with that. So they enjoyed it. But still, this is not very business-oriented. But we have the Spock reports. We just add one dependency, and it makes such a beautiful HTML page out of our scenario, which is human, totally human readable. And if the process requires that, we can put it into our project documentation as a part of the quality assurance phase artifact whatsoever. The problem with Spock I see, the problem I see still with Spock is that I don't want my testers to fiddle with the environment. I would like them to focus on actually running the test codes, not on fiddling with the environment, hitting writing scripts against one or the other environments. I would like to have them just write the code and provide the environment out of the box. So then we have two scenarios. We can have either a testing environment somewhere in our infrastructure and all the testers are hitting against it, which is quite a popular scenario. As far as the testers are only reading data, it's okay. When they start changing the data, yes, we get into another set of troubles. So what I would like to have is, besides having those tests written in some high-level language like Spock, I would like to give them an ability to spin out an environment on runtime. Like they run the tests, the environment stands up, the tests are run, and it's closed down, and it's fine. Immutable environment, idempotent tests. That's the tester's heaven, as developers' heaven as well. So, of course, there is tooling for that. Yeah, Docker. If we did the container thing or the virtual images thing up front, and we have our code packed into some kind of thing that we can shift it to production, why on earth we don't give it to our testers so that they can fiddle with that? And there is another tool, which is called Archelion Cube. Who has heard about Archelion as a testing framework? Okay, quite a few Java EE guys, right? So we have Archelion, and then we can write our Spock tests. So how it will work? Archelion is a framework that handles all the plumbing of the container management, deployment, and framework initialization. So we can focus on tests. Within the Archelion test, we have a small static method called deployment. We define what we are deploying, and somewhere else in the project in the Archelion XML, we define that we will be deploying that to YPly or JBoss server or WebLogic, or it's a Spring Java-jar, whatever. We just define it there. But there's an extension, it's called Archelion Cube, and Archelion Cube does the same, but we are not actually having the application server. We have a Docker image or Docker container with the application server. So we have one more layer of abstraction. We can say, okay, that's just more broadened, but on the other hand, if our application consists of, well, multiple microservices, or is just an application server with a database, then through Docker, we can define how it should be working together. And with Archelion Cube, just run it. We can have Docker Compose, where we define, yes, this is the app is my example service. This is an image. And it's dependent on the MySQL, and there is a MySQL image, which I define in a Docker Compose file. And then within the XML, I refer to this Docker Compose file, and Archelion is actually running my Docker. well, spinning up my containers, and then running my test against them. So my testers in Java just focus on writing this thing, and they do not really have to understand, you know, how it happens that the whole environment stands up before the tests. What is more, the Arcadian just, with some additional tricks, can provide you the exact URL how the application was deployed. So no matter whether we are using Docker machine somewhere externally, or we are using Docker installed locally, the URL is there. So we as the developers do the plumbing. This is our job. And then we can have testers who just focus on writing the actual testing within some template. That actually becomes pretty effective, because then the testers are changing their test code, test procedures, and they are committing it to the same Git repository as the whole project. Well, it might be a kind of different element of the tree, different sub-project, but it's still in source code. And I actually see the collaboration between testers and the developers on the same code. So it's becoming a pull request, and there is a discussion, oh, why are you doing that? Because, you know, you can do it a different way. And then the communication flow starts, which is really good. And that way, I think we can call it all covered, because we have test cases as code, we have the test data as code, we have a configuration as code, we have everything in our source code, so we can just do it. The code. Before I get to the pointer, I need to make a trick. Yes. So, I promised you some code, so I'll start with the application. I've prepared a very small application. It's a Spring Boot application which does the translation from Polish word to English, calling some external web service. If there's internet here, I will actually show it's running. If it's not, I'll give it a pass. I have, whoa. Okay, it's readable. Very simple application. So the main thing is this get translation methods. I pass a word and it gets translated through some service. That's not most important. There are a few other things that are quite interesting. The docket bin. This is a Spring service that is using Swagger underneath. This is kind of a Spring flavored Swagger. So I define it that we will be using Swagger too, and select the APIs, which is the actual package that I'm using in my application. And for all the paths that are in there, build the documentation. And how it's working is that when I go to my project, it's okay. And I do Maven Spring run. So I'm running my Spring Boot application. I'll take a second. Oh, no, it won't run. Sorry. I have to configure it. Now you'll know my password. It's very secure. That's my local machine. So it's spinning off, blah, 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 standard Spring thing. It will take a few seconds, unless it breaks. No, it didn't. Blah, 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 lots of less important stuff. The thing is, then when I got the application deployed, I go to my host, which is 8080, and get a Swagger UI thing. And it generates me an HTML page which describe all the interfaces I have in my application. So I can go to app, which is this one, and I have this translate word thing, which is exactly what I had in here in my code as the request mapping. And I can go to the get thing. I can see what are the statuses, what is the expected model, and so on and so forth. And I can actually try it saying, I don't have no idea what's the translation of boshebolle to Polish, and I cannot do it to English. But I can write a donut. Let's call it like this, and try it out. As you can see, if it will, yeah, it's working. It's actually calling my service, and it gives me the sample, how I can call it with curl, what's the URL, what are the response body and response code, and so on and so forth. So I have pretty much service documentation generated out of the box from my code, which is great. But it's still great for developers when I have to fiddle a little bit with the API. But I would like to also have a PDF out of it that I can show it off to vendor or to any other party to just have a written documentation. That's something I'm not actually having in my code. There's thing called Swagger to markup that based on the same JSON files that I use to generate this page. It is generating the ASCII doc document that I can use. And now talking about the ASCII doc. This is a sample project. Building it is multiple steps. So I decided to describe those steps with a documentation, with a document that shows what is needed to build this type of a simple application. So within my project, I have a second file, which is called manual.adoc, which is ASCII doc document, and it actually describes the whole process of building the application. So I have the title, Spring Boot Showcase, blah, 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 example context, and then I have something called plant.uml. Who has heard about things like diagrams as code, or ASCII diagrams, like plant.uml, data diagrams? Yes, this is a hipster of documentation, pretty much. So here is a sample of plant.uml. So this actually, what you see on page, prescribes the diagram. It defines a node that there's a Spring Boot application, there is a second node, an external service, there's the database, and it shows some interaction between the documents. And then it describes how the application is built. So there is a REST controller, which is a source. And you see, I'm not pasting anything from the source code. I'm actually referring to the actual documentation. So I said, OK, and here include from base directory, from POM.xml, tags, dependency management, and then dependency web, and build plugins, and so on and so forth. Within my POM.xml, which is here, I've defined those tags. So I have some comments, which are tags, and ASCII doc parser just knows, OK, I'll take it from there and parse everything that's between those comments. It's smart enough that it's working not only with XML, but also with some Java code, if I have it here somewhere. No, I didn't have it. I had it some. No. You can also put it in the source code, also a comment with a tag, double colon, and then the description, and you can refer it as an include to your application. Or you can, if you're not fond of tags, you can just include lines from 70 to the end of the file. It's all fine. And then if I have a document like this, what I can do is I can go to the to the folder, which was called ASCII doc. I have manual and I have ASCII doctor parser, which require ASCII doc diagram, ASCII doctor diagram, if I remember the syntax correctly. And then I go manual, and it renders an HTML page, which pretty much describes what I've been written in my code. So this is the graph that's actually got generated, and these are all the snippets from the source code coming actually from my application, which I found quite handy. But obviously, no business would like to view. No business people would like to view HTML pages. So I have ASCII doctor PDF with these diagram. This -r, it's an extension I'm telling is require ASCII doctor diagram to parse the thing. And then I do manual ADOC. It takes some time, and as you can see, I have a PDF, so I can go Acrobat, manual PDF, blah, 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 blah. And this is exactly the generated PDF file. So I got everything I needed from the documentation inside my code, and I can just generate it. Obviously, it is not that fun that I'm typing it. I can put it in a build script, so I have a build Gradle, and this is a Gradle script that actually runs and converts all the ASCII doctor within my project to the HTML. Yes? Yes, including the diagrams. So I can have this generation of the documentation as a part of my continuous integration flow, which is very handy. I've been shown 2 minutes. So it's either I can steal some of the break and show the Archillion and the Docker thing, or you have some questions. Questions or questions? Archillion. Thank you very much. I feel so the Archillion thing. There is a very nice project within the. If you've been playing with Archillion, one of the struggles with Archillion is like, I have no idea which version I should take because there is hell a lot of them, and they are changing because most of them is in alpha stage. At least that was my struggle with Archillion. So I have a thing called Archillion Cube. There is a nice project called Archillion Universe, which is an alpha stage now, but it's a bill of materials for Archillion. And then if I use Archillion like Docker or JUnit, I don't have to reference the versions. The universe has all the latest goodies that are stable and available, so it saves some hassle. So what I would like to get is to get into a situation when I have a pre-baked project which is using Archillion with Docker, and it will be the whole project will spin out the containers, deploy everything. But we've agreed I have a few more minutes. It will spin out the Dockers and will run the actual tests on the application. So first of all, the Docker image or the Docker container for my applications. I tend to put it in a separate project. I don't want I not always want the Docker itself be part of my main project. So I have a second project which is called Spring Boot Docker. It has a reference to my example application, and I am using something called Docker Maven plugin. There are like a handful of those. Where within the XML I describe the actual Docker file. If you're familiar with Docker, you know that there is this from where you define the base container and then you add some additional things. So what I'm doing is I'm actually including the project dependency within the Docker container, and that way, if I go to my Docker images, when I run let's here. When I run Maven Docker build, it will grab my dependency. If there is internet, okay, it's working. It grabs my dependency and creates a new Docker container within my local environment. So now I have the container. So now I can work with Archillion, and that way that I can either through Archillion compose or directly in Archillion file, I can define that. This is an Archillion configuration. So I define that there are some Docker containers I would like to run up front, which I prescribe. I have the app container, which is building an image based on a template and the template reference to an image I already have. And it's dependent on the MySQL, which is also an image coming from Tutum a ready-made MySQL image. And then, as a next step, I say, OK, the Docker container, let's just run the container called up. In general, Archillian is about building your application and deploying it to the container, not Docker container, but application container. So you build a WAR file and deploy it to JBoss, or build a ER file and deploy it to some other application server. The thing is about the containerless container is that Archillian does not need to care whether you're deploying something or not. You're just spinning out Docker, and it can assume that everything is in there. The Archillian cube is still in the alpha stage, so it's changing quite much, and not everything is running like this beautifully, but this is something to look into. So if I have this Archillian defined, then I have my translation test. Within my translation test, I have this deployment part, which I have to do. It's empty, but I have to do, otherwise Archillian is getting weird. This is going to change in the next release. And then I have my actual test case that has been defined, that has been shown on slides. So my testers, or as an engineer, I focus on this test part, and Archillian focus on that my test will actually run in an environment that it will be calling the actual application. So let me show it. I will go to the cube, and this is the last example. And I will run Maven test and then this testable translation test. It will take a while, but in the meantime, on the different screen, you see it's running the test, and I will show you, come on, Docker. That's the advantage of semi-live coding. It can just take some time to run. Okay, if I go Docker, you see that it's actually up and running. It deployed something. If I do the logs of my app container, you actually see that it has been called with the translation. So the Archillian actually spin off the Docker's images, run the test against it, and then when I do Docker ps-a, it just removes everything, and my test status is okay. It's run. The downside is it took 1 minute. So this is definitely not a unit test. It's more of an integration test, and we spin out the whole environment to run this test. That's a kind of a downside. But on the other hand, everything I needed to run this test was actually in my source code. And whenever somebody changes it, I have visibility and I know what's going on. So getting back to the presentation as the finite pointer. 3 more slides. Yes, we got the tools. I think we got most of the tools we need to get everything as code Notion. The problem we have, and at least problem I struggle, we have to crunch some walls. It's not easy to make operations guys change their behavior, or it's not easy to talk differently with the business. That's the biggest challenge. And it's exactly the same challenge we have when getting through, for example, microservice architecture, where the technical challenge is not a problem. The problem is change in people's mentality. So yeah, we have to change the organization a little bit. That's the hard part. So any questions? That's all for me. If you would like some links and goodies, you can follow me on Twitter. You can catch me up on Twitter. The presentation is online, and the core code is within the GitHub repository. Obviously, this presentation was done with ASCII Doctor, and you can see everything online. Thank you very much.